Hi everyone, welcome back to Coding and Analysis. And in this video, I just wanted to, I forgot that in the cross validation, finding the best iteration of boosting rounds, there was no feature importance. So I decided to go in. It's a little bit more difficult to add the feature importance for this XGBoost cross validation, but I went in and added it. So we have our 5-fold cross validation with early stopping to avoid overfitting. These are the parameters that we're using. Number of boosting rounds is 150, and then we're determining the best iteration or the lowest validation MAE in the boosting rounds. And then we're training our final model using all the data, the best number of rounds. And then here we get the raw. This is how we get the raw feature importance scores using gain. It's the total gain across all splits using the features. So we make our importance dictionary, and then we say model.score, and then we use importance type as gain, and then this dot score comes from the XGBoost. And then we get check if model has any boosting rounds importance values. So we're just doing it this if else logic. So we're converting the importance dictionary to a data frame. So we want our features and our importance and then the position. So the raw importance is going to be the raw gain values. Can be very large, and then we want to see it on each position. And then this is how we're going to normalize the importance values to sum to 100% for easier comparison between features. So we're going to add a new column called normalized importance, and then it's just doing the having this important. So I guess this is a new column here, importance underscore df data frame importance dot sum method, and then the normalized importance, which is the importance times 100. And then we're going to print the results just like we've done in the previous videos. And then if with our else logic, if there's no boosting rounds, we'll run early stopping at 0. Feature importance will be empty. So no feature importance like we do to 0 boosting rounds. So that would print out that result. And then we're generating our predictions for the entire data set with our model.predict. So, and then this is the end of the function. So we just have to remember what's coming out of the XGBoost is xgb.train. So the .train is coming from the XGBoost library. .get underscore score is coming from the XGBoost library, and the model .predict is coming from the XGBoost library as well. So I ran it, and one thing I wanted to do is I just wanted to take away the projected roll column. So I took that away because I didn't really want to see 50% just being the top feature importance for the quarterbacks or 40% for the running backs or something like that. So I just took that column away, and I'll look at the results. I added the results to the spreadsheet, so I'll look at that later on. So right here we see the performing cross validation for running backs is the best MAE was at 35 rounds. So, and then here's the feature importance. So it's rush attempts at 44, receiving yards let's see, what is that? Receiving receptions at 12%, 2023 receptions. Health grade was 9.4. 2024 rushing touchdowns, 7.9. 2024 receptions is 6.3. 2024 receiving yards is 3.36. And 2024 receiving touchdowns is 3.14. And then cross validation for the wide receivers, tight ends, and we're getting the best MAE with at 53 rounds. So we can see here it's the 2024 receptions, 2024 receiving yards, 6.3 for the 2023 receptions, and the age, 2025 age, 6.22%. 2024 receiving touchdowns is 5.29. 2023 total touchdowns is 4.9. And then we go to the quarterbacks. The best MAE is 63 points at 33 rounds. And instead of this projected roll at 50%, we're getting more of our stats that we added in. So I wanted to see all the stats being configured into the model, adding into the model and the model determining off of that instead of just one column. So we have 2024 passing touchdowns, 2024 rushing touchdowns, 2023 passing yards, 2024 rushing yards. And then touchdowns, total touchdown 2023, fumble loss 8.17%, health grade 7.5, adjusted risk 7.34. So I wanted to see, I don't see I guess the 2024 passing yards was not included. It cut it off, so it wouldn't be, because we were talking about these parameters, the alpha and the lambda. When you're doing the alpha, the L1 regularization, you're trying to knock off all of the dead weight. So I guess it was considered dead weight. So 2024. Let's see. 2024 passing yards. Let me go up and see. Do I have the passing yards in here? I thought I had the passing yards. Yep, 2024 passing yards. So I was close to zero, and that our parameter knocked it off. And the feature importances. So we have the 2023 passing yards for whatever reason, 11%. And I guess the 2024 passing yards was close to zero, and the parameters that we set kind of just knocked it off, which is interesting. You can't really explain what the model is doing, but or you can't explain how they're factoring in for the most importance, the most feature importance. But then if we look at the random force regression, so I went and I took that off as well, the projected values, the projected roll. So 2024 passing yards for the regression model was only at 0.02, so it was only at 2%. 2.1%. So that's why the cross-validation model had cut that off. So if we look at the metrics over here, we get 0.942. It's only 17 points off. Wide receivers tight ends 0.94, so all close to 1, and quarterback was 0.955, so only 14 points off. So once we did the remove the projected roles, it made the it scored the quarterbacks. I mean, I think it gave the quarterbacks a better R-square score and a better MAE score. So then if we look at the results right here for our cross-validation, so we have, so there's no more Joe Burrow down here. It's Cam Ward, Omarion Hampton, and Rashid Shaheed, and Brashal Tootin having above the projected points. So I guess our model has him like at 160, 170, and the ESPN model had him like at 60 or something like that. And then Kayshon Boutte, so ESPN had him as 0. So if we look, so ESPN model has him at 63. Our model has Tootin at 172. Boutte is 0. Our model has him at 91. Then, so Jackson Dart 130. Our model has him at 187. So if we look at the undervalued players, so Cam Ward, ESPN has him at 255, and our model has 187. Omarion Hampton 239. Our model has 176. So this is good. This is all interesting stuff. Not really, the valuation differences aren't really off. Only 67, 65, 64 points. So not really too bad. The only one off was really Brashal Tootin, which our model considers, really likes Brashal Tootin, which if he gets the chance, I'm sure he can, because I remember Etienne and Tank Bigsby. I think they've all kind of dealt with injuries in the past. And then if we look at the regression, so I took away the projected role. So we have rushing touchdowns, rushing attempts, receiving touchdowns, receptions. So really, it's the bulk of it is rushing touchdowns. Bulk of it is the 2024 stats, and then the bulk of the wide receivers, tight ends. It's receiving 2024 receiving, 2024 receiving, 2024 receiving touchdowns, 2024 receiving yards, and then for the quarterbacks, it's passing touchdowns for 2024, passing rush touchdowns, 2024 rushing yards for the quarterbacks, in 2023 passing yards, and then our 2024 passing yards for whatever reasons down here at 2%, which the cross validation feature importance did not include. But really, it's good that the model is including these rushing touchdowns and rushing yards, because the mobile quarterbacks are the most important quarterbacks for the most part that you can draft in fantasy football, especially in really in both leagues, PPR and standard half PPR. They're valued the highest, like Allen and Jalen Hurts and Lamar Jackson, Jayden Daniels. So it's good. I'm glad that the model is including the rushing touchdowns and rushing yards for the quarterbacks. So let me go back to so really nothing too far off in our chart, so that's good. And then when we were doing the feature importance, we were calculating the feature importance. We want the sum of the importance, and then the importance divided by the total times 100. So that's why we're getting right here. So we got the total, and then so we got all these points, then we got the total, and then this was calculated from the total. So rushing attempts 2024 is really the most important, and then kind of weird they have 23 receptions is 12%. Health grade, that's good, 9.4. Rushing touchdowns, receiving receptions 7.9, 6.2. The wide receivers, tight end, that's good. That the receptions is the most important for 2024. So rushing attempts, receptions, receiving yards. I sort of wish the touchdowns and receptions would be up here instead of the 2023 receptions, but keeping I guess remembering the prior season is also important as well, because we just don't want to go off of one season. We want to go off of the 2023 and the 2024 seasons, so we can blend those results together to find a more accurate prediction. And then it's good that I'm glad that our models, the quarterbacks, is using passing touchdowns, rushing touchdowns. I just wish the 2024 passing yards was used here, I suppose. But like I said before, with these 2023 receptions, it's important to have the 2023 stats included as well. So, and they are included: 11% for passing yards, 8% for touchdowns, 8% for fumbles, lost fumbles. So what I did here is I made this spreadsheet. Let's see if it pops up. Here we go. So I made the spreadsheet and I brought in all the data, the Roto Baller tiers for the players, the Roto Baller rankings for the PPR. You're in a PPR league, and then the CBS PPR points, ESPN PPR points, and then the full training that I did, the model that I ran, the XG Boost regressor model that I ran, the XG Boost cross validation, and finding the best model that I ran, and then I averaged these all out. So in the next video, I'll walk through this and give my final thoughts on this project that I did. See you on the next video.